So, hi everyone, my name is Fabio. I'm a postdoc working here in Denmark, and in this video I will show you a major part of my daily workflow, which is how to take notes. I'll share you how I take notes about the subjects that I'm researching and studying and learning, and I think this would be useful for grad students, general types of students, and also for professionals that work in more like knowledge intense kind of job. So let's get into it. So the app that I use is called Obsidian, and here on YouTube you may find a lot of videos, a lot of tutorials about YouTube. It's a great app, it's free to download. You can download it and start writing your notes. There are some services that are paid. I personally use the sync service because you can use Obsidian and sync your notes using like OneDrive and iCloud Drive and Dropbox and everything like that. But the trick is when you have to combine different platforms. So for instance, if you only have to synchronize between like a Mac, which is what I'm using now, and a Windows PC, you may use a service like that. If you just use Apple products like a Mac, an iPhone, an iPad, you can use iCloud Drive. The trick is when you have to combine different services, because for instance the mobile version of Obsidian does not support external providers like Dropbox or OneDrive, so you have to use iCloud. If you use on Linux, which works very well, but not all of the services have Linux apps, so it can get a little bit tricky. So the sync like plugin for Obsidian is a native way to sync notes between different platforms, and it's not that expensive. I think it's worth it. So in terms of plugins, here is my Obsidian setup, and here on the left are my folders, and this is called the para method. And if you like to know more about how I use the para method, how I organize my notes and also my files and everything like that, leave a comment here down below and I'll make a video about that. So in terms of plugins, you can look many types of plugins. There are lots of videos talking about amazing plugins. For this video, we would keep things simple. So the only plugin that I use actually is a core plugin, so it's not a community plugin. It's not something that you can download from an external website. It's a core plugin, so it's come right into the app, so it comes with the app. And the only thing that may be unusual from what I speak with other people who use Obsidian is this unique note creator. So what we'll do is that when we create a note, it will create a title with a unique ID, so a unique timestamp for that note. Let me show you how that works. So if I create a new note and with the keyboard shortcut Command N on Mac, which would be Control N on Linux or PC, you see that it creates a note with a timestamp. So the year, the month, the day, and the hour, the minute, and the number of seconds. If I create another note, you see that the seconds here are different. Why is that? This is based on the Zettelkasten method that I studied a lot, like 10 years ago or something like that, when I was transitioning from my master's studies to my PhD. Is a way to abstract each note from its title. So you can write a title like video ideas, and later you decide that this is not a note about video ideas, this is a note about video projects, and you can change the title to be more meaningful, but the ID does not change. So it's a unique ID, and even if you change the title, you can always identify the note by its unique ID. I find this very useful because when I search for some note, I can always say, oh, this is a note that I created in 2016 and 17. For instance, if I open a note with Command O shortcut, I can type 2017, and you see there's a lot of notes. And this is from a time that I didn't even write the title besides the note. If you go for something a little bit more recent, like 2022, for instance, there are a lot of notes here, and I cannot even remember which note is about, but you get the point. So to configure that, the shortcut that I just used, Command N or Control N, will create a note without that. So it just creates a title, and you can type anytime you want. To configure that, you can go here to the unique note creator, and I use the inbox folder. So anytime I use this plugin, there's where the notes are going to be created. This is the format that they're going to use. So 4 digits for the year, month, day, hours, minutes, and seconds. I don't personally use templates that much. Maybe I'll talk about in a different video. But here on the hotkeys, you can type here unique note, create new unique note, and there you can define a new shortcut, because that command, that shortcut is usually attached to new note, like that. But I never want to create a note that is not a unique note with that ID on the title. So this is my configuration, very simple. This application is very, very useful. So what is the workflow? I want to learn more about something. I'm trying to use some technique and some method, and I'm not understanding very well. So this is where I open Obsidian and I try to write a note about it. And one thing that I like to emphasize is that it's not that often that I will check the notes or read the notes in the future. The most useful time for me to writing notes is when I'm writing the note, because that's where I'm thinking about it, I'm reasoning, I'm planning. So the notes will be stored in Obsidian, and like in a week from now or a month from now, I can read them again and see, oh, how did I do that? But the important part for me is not checking all notes, is writing the note right now. So I'll give you an example. I hope that it's not too difficult to understand, but this is a real example from my actual day job that I'll share you how I study something that I do not understand very well. So the problem that I have is that I use a simulation program. I am an engineer. Called COMSOL, and I have to currently I'm in a project that I have to simulate some magnetic particles. That's not important. I cannot even share all the details, but this is very generic physics engineering type of problem. So this is one part of the interface of the program. It's a relatively complex program to operate. I've used it extensively in my PhD and my previous postdoc experiences. But the thing is, the simulation is not working. So that's the problem. And there's something there that I'm not understanding well enough to make the simulation work and make me able to calculate what I need to calculate. And the point that I'm stuck at now is this solver configurations part. So that's what I want to understand more, how that works and how can I tweak all the different kind of settings in the buttons so that I'm not a just button presser kind of person. I want to understand a little bit more. So let's create a note, and we can let me delete these notes here, and you can see that I can create, right click here, and let's create a new note, and let's say console, and the This is the solver configuration. So let's write that console solver configurations. Okay, so what I want to understand. This is like a tree of configurations. So you have this solver configuration thing, and you have this solution thing, and here you have three other things. You have this compile equations, you have this dependent variables, and you have this stationary solver. And below that you have different kind of levels. So I'm thinking this in real time. Probably I can just transcribe this tree to Obsidian to start to think about it. So I write something like that, the problem, and I have terrible typing, don't mind that. How can I configure properly console settings? And the solver configurations is under the study node of the model builder. So let's see. Under the, and here I'm writing in Markdown, so I can italicize words between asterisks. Under the study node, console creates a, what is it called? Solver configuration. Subnode, which consists of the following. And so actually consists of a solution node, like solution 1 here, and that node consists of all these items here. So let's correct that. Creates a solution node. Actually, that's not correct. Create a solver configuration subnode. With a solution tree, which consists of the following. So here I can like create subsections of this node. So let's say compile equations stationary, dependent variables, and stationary solver. And so that I don't have to like alternate between Obsidian and the preview here, Obsidian allows you to embed image files. So let's try this. I think I can just drag and drop here. Oh, it worked. So it grabbed a copy of that file and put it right there. So this is much easier. And by the way, before we continue, these nodes are actual text file in the computer. So if I open the configuration here, here on the file and links, I have this attachment folder path, which is where does the things that I drag and drop get stored. So I created a folder called media, and I won't be able to open, but it's called something like console and something. Here. So this is where the actual file, the copy of the file got placed. And where do these nodes live? When you open console for the first time, it will ask you where do you want to put the files. In my case, they are in documents, or actually not. It's in my home folder, I think. Yes, it's in my home folder. So my home folder is called FP ForgeCamp, and I told Obsidian to put the nodes into a nodes folder, and we can see our current node here. And this is just text file, so you're not locked into the Obsidian database. I can open this file here with, say, Visual Studio Code, for instance. Let's see if that takes a long time to open. And right there. Of course, Visual Studio Code won't have the sort of intelligence of Obsidian to see that this file here is actually under a media subfolder. But you get the point. You're not locked into the Obsidian database. So let's go back to our note here. And the thing is, I think for this video I will focus on the stationary solver part. So what is a stationary solver? This is from my experience with Console. The stationary solver solves a physical problem in a steady state, i.e. not changing with time. I think it's reasonable enough to understand. And the solver will solve a linear system, so a linear system of equations. What console does is you create a model, and it sort of creates a system of equations that you try to solve. You can specify some of the equations based on the model that you're using. This is not an engineering video, but it solves what these things called solve a linear system. And if you want to learn more about linear algebra, I'm thinking about creating a series of videos about that. Leave a comment here as well. And the solver will solve a linear system of the type, and I can type LaTeX, so math notation. So a times a vector x equals a vector b, and where a is the matrix. And maybe you can use boldface for the matrix. Okay. So the solver will solve a linear system of the type ax equals b. So it will create the matrix of coefficients a, and will create the vector b, and will solve for the x. Like so, that would be the temperatures that we are trying to calculate, or the magnetic field in this case, or anything like that. But for that, you can have only one of the two types, a direct, and let's create a list here, so a direct or an iterative. So notice here that the direct is enable and the iterative is not enable. And if I went to console, I don't have console in this computer, but if I went in console and enable the iterative, then the direct node would be disabled for default. So it can't have the two of them at the same time, because this is the method that you use to solve the system of equations. And from what I understand, the direct is a method where it always converges, because you get all the equations at the same time and you solve them all at the same time. So if I'm correct, we can say that it always converges or gets stuck. This is the actual problem that I'm experiencing in this project. But it's not that the solution will be some number that it's like crazy number, impossible to achieve. No, the solution is like contained into some interval. But it does not blow up, like calculate some infinite numbers or something like that. And might be a bit slow for some problems. And the iterative type can be very fast to calculate, but can also diverge. So you have the solution. We will start with some initial guess and we will try to iterate on that solution. And if the guess that you provided is more or less correct and the system is well behaved, it will converge quickly and you calculate and solve the system. But if the matrix or coefficients, like if the geometry is very complicated and the materials have some weird properties, it will try to iterate, and then will blow up. Like the numbers, it will calculate something like infinite temperatures and something like that. So this is good to have in mind. I think that for my problem, it's better to stick with the direct methods, but I have to think about how to accelerate the process. And what I'm curious about is what are these like advanced parametric and fully coupled. And in order to make this video not too long, let's concentrate on the fully coupled node, and let's create like a tree here. So the stationary solver has a direct and iterative, and it has a fully coupled configuration that I'm not very certain how it works, but I'm showing you how I take notes about the subject. So here I have the console reference manual, and I also have a shortcut. So console, I have these screenshots here, and let's see the fully coupled settings. So let's put that into our note. So this is the fully coupled settings. You can see a lot of numbers, and this is the part that I'm most struggling with, what all these numbers mean. So we can open here the console manual, and let's see if I can search for fully coupled. The fully coupled attributes. Okay, solution attribute, that makes sense. And here, okay, the fully coupled attribute node use a damped version of Newton's method, or for stationary problem, a double dog-like method to hunt parameters for a fully coupled solution approach. And here what I can do is this. I'm not understanding this. I have to study a lot more. But what I can do here is like copy this. So let's copy this. And we can create a quote with the bigger than sign, and then like that. And we can create like from the console reference manual. And I'm see here this double dog-leg method to handle parameters, which I have to research. And I see here that there is method and termination. And here we have an explanation, and we see here that we have an explanation here for all the parameters here. So for instance, let's just write some more. So for instance, method termination. Select a non-linear method to control which damping factor to use in the damped Newton iterations. So let's copy that, and let's see. And I think instead of a quote, I want to write in my own words. So under method and termination, you can select which method to control the damping factor to use in the damped Newton iterations. And I ended up copying the manual word by word, but I don't think it matters now. This is just for me. And so I'm hearing a lot about this damped Newton iteration. So at this point, I would create a new node and link from this node. So I have a text expander shortcut, and I'll create a link. I'll put a link for text expander in the description, and I can see the ID. So I would say something like that to control the damped Newton iterations. And I can, so what I did here is, in Obsidian, if you create something like bracket and some text, Obsidian understands that the text between these double brackets is a link to a node. So it assumes that you have a node called 2024, 1127, etc. And if you command click or control click, it will jump to that node, or it will create if not existent. So I have a link here from this new node, and at this point I would research more about what are damped Newton iterations, and I'll write something here. Maybe I'll create a new node, and this is how I study the subject. And of course, in the real life, this will take hours, maybe across a whole week. But in the end, I have a bunch of notes that illustrate my thought process, and when I actually using console, I can check my notes and see, okay, this parameter is that, this parameter is that. This parameter control the damped Newton iterations, which means that, and so on. So this is how I take notes, a real life example. I hope it was not too complicated. Please like this video and write a comment saying what you think, and if you want to know more about my workflow as a researcher here in Denmark. Thanks for watching, and see you in the next video. Bye bye.